It started. Hey guys, welcome. This is our fifth session. So we are completing the fifth session. Thank you so much, Abhishek, for your patience and consistency. This is the fifth session that Abhishek is going to deliver, and it's quite a technical topic. We are discussing Python, we have discussing Jupyter Notebook, we have discussed web analytics and few other analytics techniques. So I just want to give a quick recap how you can access the previous recordings if you have missed or if you want to go through the recordings again. So on your screen, you will see this is the web page, digitalmarketinginstitute.in. You can just head to webinars and all the recordings are available here. So all four recordings are available here. I will continue to update this web page, and all the new webinars which we conduct will be hosted here. So Abhishek, over to you. Why don't you start with a quick recap and then we can proceed with the content of today's session.
Sure. Thanks, Ashish. I hope you guys can see my screen.
Yes, I can.
So it's a PBT, correct? All right. So let's talk about the agenda for today. So we will recap what we have done so far in our sessions, and then we'll talk about segmentation, like why segmentation is needed, and why in machine learning and data analysis we do segmentation. Similarly, we will move forward to talk about association rules. So like when we do the data analysis, we need to understand the relationship between different variables. So we'll discuss about the different techniques for association rules. And then we'll discuss for a short period, we will also talk about some of the digital marketing concepts. We will not get into depth of the digital marketing concepts, but yeah, we'll just touch. So to talk about the recap from our last sessions, we discussed in first two sessions, we talked about the web analytics, importance of data collection, and several techniques of data collection from different sources like website, mobile app, and OTT devices. We discussed the Adobe Analytics features. We discussed the Google Analytics feature. Those are the primarily web analytics tool we talked about in our sessions. And then we discussed the difference between web analytics and data analysis also. And then we dived into Jupyter Notebook. We started working on Jupyter Notebook using Python. And then we started taking some of the data as examples. And so far, we have done three major things on Jupyter Notebook using Python. We learned the techniques of data cleaning. When we look at the data, how we clean the data, what are the different aspects of the data cleaning we should be focused on. Second, after cleaning the data, we looked at to create a plots, different graphs, how we can look at the different relationship between variables using graphs on Jupyter Notebook. And then we looked at a linear regression model. We used a standard linear regression model and multi-linear regression model, both technique. We discussed how we basically understand the efficiency of a model, how we basically try to figure it out whether your model is good or bad. We discussed all those things. So far, any questions on these topics? I'm happy to answer any questions before I begin. Okay, no questions. Great. So let's move on to data segmentation. Segmentation is the key of any marketing analysis, or whenever we run any marketing campaign, we have to have segmentation. Otherwise, we cannot achieve what we want. Like suppose our goal is to sell a certain number of product in a certain region, then we have to have a segmentation in our marketing. And how we do the segmentation, there are several techniques on Google Analytics. You can create the segments by just button click. On Adobe Analytics, you create segments by button click based on different options what you see. So those are the inbuilt segments already there. In Tableau also, you can filter the data easily. So sometimes people feel that segmentation same as a filtering. So for example, if I apply a filter and then store the filtered result in a separate data set, is that segmentation? So any thoughts on that? Have you guys ever worked on segmentation and data filtering in your data analysis in the past? Feel free to speak up, not a problem. All right, looks like nobody has done that, but yeah. So that's a little bit confusion in the world of segmentation when you filter the data and pass into a data frame, and then you feel, oh, we have segmented our data. You know, in data mining, we look at data segmentation in a different way. We look at data segmentation like how we have created different segments of the customers or any data. That means how we have created different clusters of the data, what we are looking at for analysis. And then when we create those clusters has some common meaning together. So suppose we are looking at five variables. For example, we are looking at age, we are looking at income, we are looking at spending, and then we basically run the segmentation algorithm. Then basically segmentation algorithm will automatically create different clusters, and it will create the cluster in such a way that people who are earning less will be clustered together with the low earning people. So that's the algorithm we will use, which we call k-means clustering approach algorithm. So we'll explain what k-means is and how it works. Before that, let me give you a couple of examples of segmentation in the real world when you go to when you go to the professional company. So for example, when you are doing a data analysis for data from Amazon, okay, let's take a simple example of Amazon, which sells a retail product, like any product, you know, and uh, and Amazon would like to understand how many people are my like how many people, like out of my 100 orders, how many people are the buyers of my high valued product or highly rated product. um, if customer is buying highly rated product, then segment that customer in that segment and show them a different products, so that their buying behavior will not get impacted, and they can earn more money by showing them a higher quality product, or I would say higher price product, and they will have more earnings in that way. So when you segment your customer or your customer's data, um, there's always a objective of return. Like when you segment what you want to achieve after the, just like linear regression model, it predicts something, right? It will give you prediction about your revenue, your orders in future. But here in segmentation, when you run k-mean clustering approach, you have to use that output for something good in your next input. So that's one thing you should be aware of. After doing clustering, you need to take action. You need to take some action on that data, what you basically got after the clustering algorithm. Okay, so segmentation, as I said, is really important, very important for personalized marketing and personalized targeting. So for targeting, we use data segmentation a lot. So if you don't do data segmentation, highly targeted marketing is going to be less likely you will achieve anything. Um, any question?
Yeah,
Uh,
I just want to chime in for a quick few seconds. So the kind of segmentations, like especially in the web or the e-commerce part of the world, the kind of
yeah,
segmentation they use is whether the user is male or female, what's the age group, even the country or the state wise segmentation. Uh,
yes,
what's the user's previous history with the organization? How much dollar that user has spent? So all these things people take into consideration while taking decisions or while rolling out the offers to that people. Say for example, if it's a lipstick brand, they don't want to roll out their offers to male. Uh, so they create a segment. Whoever is the female visitor of the website, show them these banners. So that's the use of segmentation in the retail industry. Over to you, Abhishek.
Yeah, absolutely. That is fantastic example, Ashish. So when you do those segmentation, as I said, when you create those segmentation in your data analysis, you need to pass the result to some other team, and that team will basically take that data to do some action. For example, as you mentioned, to show the banner. So the marketing team will decide what to be done for those segmentation. So your as a data analyst, your job is to give me the segment or give me the cluster, I would say, and describe me what this cluster means. And then the marketing team will take action further on those clusters. But it is important for you to explain what these clusters mean to the business. Otherwise, you got the clusters, but you don't know what these clusters mean. What are the common behaviors of the clusters? You need to simplify those things for the business. And then the business will take action based on your output. Okay, so the k-means algorithm is really popular in creating clusters in data mining. It is unsupervised machine learning algorithm where where basically you uh, uh, try to calculate the distance between a centroid of a cluster and each elements of the clusters. And as soon, I mean, this is a very repetitive process. So Python provides a package which we're going to use, but if you are a Python programmer, you can rewrite the whole logic by yourself in Python. So we will use package because it makes our job very easy. Python has so many machine learning package. That's what we have been using so far. So when you use this K-mean algorithm, inside that, what it does, it starts with one iteration, and it basically create one first centroid, and then around that centroid, it basically start checking the distance between the different items, and keep repeating the same process over and over until unless it's create different centroids, and it makes sure that all the elements, distance of all the elements are aligned to a certain centroid. So that's what it does in the background. And it's a very simple, I would say, algorithm. It's not very complex. What we are going to do, we are going to take a simple data set. We are going to use a simple data set, and we run through the steps, like whatever required to create a cluster. And I will show you how you can use it in your data analysis approach. Okay, so let's get started on that part. Before I will wait for like 1 or 2 minutes if anybody has any questions.
So I think there are few people who are not able to join. I have like 5 to 6 emails. Uh, People are saying that they're not able to join the Zoom meeting. I'm not sure, maybe some Zoom issue or some technical outage. Just for your information.
Okay, yeah, I'm just trying to see a lot of people are joining now, but that's great. That's really good. So as we are here on our Jupyter Notebook section. We'll go and click on Python 3. We are using Python 3. So we'll say session 5 demo. So our goal is to create clusters. And first, we should also aware when we work on any data analysis, as I said, any data analysis runs with a goal and objective. So you need to know what you're going to do with the cluster. And then you start doing the data analysis. So let's start doing that. So I have a data set which is very simple. So let me get the data set, and I'll import some of the library here, like NumPy library and Pandas library, and then I'll use the pd underscore read csv pd.read csv file for the file. So let's take a quick look. So this is the file which we will be using. And let's look at the content of the file. We'll see the 5 first element. Head by default gives 5 first element. You can add 10 also, which will give you 10 first element. So this is the data looks like: customer ID, gender, age, annual income, and spending score of these customers. So very straight, right? So when we do df.info, it can tell us like, okay, how many rows and how many columns are there. There are 200 rows, there are 5 columns, and these are the different data types of the columns. So far so good, right? Now let's take a quick look on few things. What I'm going to do, I'm going to do a little bit of exploration here, but not very heavy, but very basic. Okay, I'm going to use matplotlib and seaborn library. As I mentioned, we have been using these libraries for our plot, so we'll use that. And then what we are going to do, we are going to plot a simple, we are going to plot a simple distribution plot. So let's plot distribution of age. So we'll use this plot, and oops, use this plot df, and then we'll give age. Okay, let's see what happens here. So this is the distribution of age. So most of the people are basically from 18 till 60, 70 years old. But a good chunk of people are beyond, beyond 30, 30, 38. From 38, there are like a lot of people are above, above 30, as you see, not much young people. So that's a distribution. It will tell you like how data is distributed. So when you look at the distribution plot, it gives you like how data is distributed. Similarly, you can create a distribution plot for every other variables, just for understanding like how the data is distributed, nothing else. Now let's do one thing. Let's try to group the customer by gender and age and see how that works. So it's very simple. Let's create a customer group. Yeah, just say customer group. So grouping is very simple. Last time also I used this group by function, and as I said, you can group by through any column of your data set. So let's use group by gender. Okay, and what we are going to do, we are going to um, group by, and let's just run this and see what happens. I just want to give you a little bit of flavor of simple thing. So we have group by people on the gender. So that's how data looks like. What as you see, male, male, female, female is together, but I think nothing has happened. Correct? Nothing has happened. So we will group the data with the gender and age together and see how that works. And
Abhishek, maybe you should
we'll,
use. No, go ahead. Go ahead.
we'll we'll using some. Go ahead, Ashish.
No, I was going to tell the same thing. Go ahead.
So we are basically grouping the gender with age. So as you see here, um, we are seeing some females with age. So it's basically we are taking the head function. So that's why we are seeing only female. We can run, see, it will say male also. So that's how it groups. It groups the gender, age, and it gives the sum. Okay, so this is how you group your customer and try to understand how your data is distributed between male and female. You can draw a pair plot also. You can do a pair plot, which can tell you pair plot. You pass the whole DF and it'll tell you how data is distributed. Remember, we discussed the pair plot last class, and it will tell you the complete data set distributed through male and female and everything. So you can add few things here. So let me show you. One important thing you can add here is you can add hue, which basically can give you an idea about how the pair has been plotted against gender. So this is simple, but it gives you an idea about the distribution of data according to the gender. So as you see, male and female here, and the customer ID. I feel like customer ID is not required. So let me add you one more important thing here. So when you do data analysis, if you are using any unique variable for every row, for example, customer ID here. When we are doing customer ID, customer is nothing but a digit, a numeric variable, which which is not having any unique data. You know, in clustering, we are basically trying to focus on the properties of a customer. We are not going to make a cluster based on the customer ID. So doing such analysis, you can drop the customer ID also. Okay, any question?
Yeah, Abhishek.
Yeah, go ahead.
So I am this is this the same is group by in Python? This is does it function as the same as it does in SQL?
It works in the same way, but
Okay.
only syntax varies. Yeah.
Okay, perfect.
Yeah. And there are SQL libraries also which you can import, and you can convert the pandas data frame into other data frames, and you can apply the SQL command directly over there.
Perfect. Thank you.
Yeah. So let's use this. So what it will drop the column. Oops. Oh, so we'll specify the axis. Okay, so this will just drop our customer ID. We don't want to have a customer ID. It is not very good for our data analysis. So we are going to create the pair plot again, and now see it's different, right? So see the distribution of the age between gender, and then you will see the distribution of annual income between genders as well. So this can give you an idea. As I said last time, when you look at the pair plot, it has a mix of scatter plot and a distribution plot. So you can understand how your points are basically distributed across different variables. Now, what we are going to do, we are going to import some of our existing k-means library, like existing library of Python for k-means. So what we are going to do, let's do that real quick. And remember one thing, k-means algorithm can be applied on numeric data set, which like the data set which has the categorical column also. So we have to just label in code those columns. So for example, in this case, as we see, we have male and female here. So we are going to encode the gender male and female into 0 or 1, or maybe 1 or 0. That's one thing. Otherwise, the clustering will not happen. So before we basically apply any k-means algorithm on a complete data set, we make sure that our data are normalized. Suppose, for example, here in this case, as you see here, annual income is, suppose in example here, annual income is 15,000. Here it's 20,000. Spending score is 3981. So the best, because this is in dollar, this isn't just a score, and age is just a number, and gender is a boolean, like 0101. So we should always, when we do the k-means clustering, we should be normalizing the data. When you normalize the data, it will not affect your clustering at all. But when you do not normalize the data, you will have a different results of the clusters. So just be aware of two things before you work on your k-means. After data cleaning, make sure that you normalize your data set with all the very common variables which you're going to use for k-means. And the second, you encode, like you do level encoding for all the columns, which is categorical values. Okay. All right, so let's do that, some of those things. So what we are going to do, we are going to use the existing libraries for k-means. So we are basically importing a library, k-means, from sklearn.cluster, and then we are using importing a standard scale for standardization, and then we are using train test split for splitting the data, and then we are using decision of, let's not, I think that is not required. Okay. I think it requires this guy to no pre-processing. Okay. Skill under pre-processing port. Let me just check if I missed anything. We are having some import issue with the library on the standard scale. Should not be a problem. Let's just comment this line. Okay, we will see we can reprocess or not, but we'll show you how to process this, use the processing. We will see that. Okay. Moving toward, as I said, we should be simply using a level encoder. So we will be importing the level encoder also. So as I said, level encoder is really important. So we are importing level encoder from sklearn preprocessing, and then we are going to encode our gender. We are going to encode our gender column. So we have to explicitly encode all the columns. We can do that using different Python programs. So I just one column here, so I'm just using one line of a code here. And as we see, the label will change for gender. So it's basically says male, I think it's 1, and female, I guess it's 0. So that's how the encoding has happened. Now let's run the k-mean clustering. So in most of the data analysis, when you are running a k-means clustering, you might be using a similar sort of a code. So this is one similar sort of code I'm using. So what I'm doing here is we are creating a list here, which is find_cls. You can give any name, just a variable name, and then I'm running a for loop, and for loop is from 1 to 14. 15 times it will run. So now here we are using this k-mean variable, and we are using this method k-means variable, and it will take the value of the clusters. So what it does, so as I said, it is a repetitive approach. It will create multiple clusters. Start with 1 cluster, 2 cluster, 3 cluster. And what I'm doing with this, I'm trying to append the value of the inertia. What is inertia? Inertia is nothing but the sum of square distance of the centroid and the each items of the cluster. So it's calculating that, and it is appending for each I. So for example, if we have like 10 clusters, we are running this, we are iterating this algorithm for 10 times. So it's going to create 10 clusters, and then it will basically calculate the distances in this parameter k-mean dot inertia, and then it is going to pass that value into this list. That is the whole purpose of this code. Okay. Now, as I said, it will see so let's see what it is this. What is find_cls? So this is a list, it gives you the distance. So square, sum of squares distance, actually, not the distance. So this is the, and as you see, this number of times you will run, the number of times of value you will have this in this list. Okay, now what we are going to do, we are going to create, so why are we doing all these things? We are doing all these things to understand two things here. We don't know what is our best cluster. Like, I don't know like how many clusters I should be creating out of data. So I need to know from my data analysis based on some measure that in this data set, if I take 6 clusters, 7 clusters, then looks like this will satisfy my understanding or my analysis. So usually you cannot have a higher number of clusters. If you have a higher number of clusters, then there is no meaning of making segments, right, or clusters. Because suppose you have 100 data, and if you have 100 clusters, that means one data is in each clusters. I mean, doesn't make sense, right? So make sure that you choose a cluster, number of clusters based on some like usually we use a elbow chart, which I'm going to create right now. So we usually use elbow chart to understand where which is the best number of k we should be using. So when I draw this graph, as you see here, the sum of square distance between centroid and each element of the cluster. See, this is how the graph is being drawn here. So we are using this list to draw this graph with the number of clusters. So look at the distance, how the distance is basically falling off. And here, as you see, after 5, the gradients are like very small after that. So when you do the k-means algorithm, try to look at this elbow chart and try to find out the value of the k where you will see the large, like where you will see the largest gradient. Like here, as you see, you can choose either 5 or you can choose either 6. Whichever you would like to choose for your cluster, you can choose it. So this is one of the best way to decide your cluster. You can have your own way also. Deciding a cluster, like how many clusters you're going to use in the k-means. Now, when we decide that we are going to use not more than 5 clusters or 6 clusters in our data analysis, we basically run the functions again with the 5 clusters. And this time we are just going to run this way. K-means is equal to k-means. So remember the same line we have used here in the for loop is the same line, correct? So and the same dot fit. So we are not using a different line. We are just saying this algorithm to run only once, and where we are setting the cluster size is equal to 5. Okay. This is how, like, this is a very common approach. You can you will see when you are going to learn the data analysis here in using k-means. So let's run this. Yeah. So my function runs here. So what next? What next? What we should be doing next? What we should be doing next is we need to know how the clusters has basically formed. So we want to know the labels, like what are the different labels it has created. So if we look at the labels of our clusters, like every data set, every row has its own label of the cluster. So as the first row has label of 4, the number of clusters starts with from 0 to 4. So we have used 5. So it will start with the 0 and it will end with 4. So we have as we see, this is the labeling of the cluster, number of clusters. What we are going to do here is we are going to capture this value in one of the variable. So we'll pass this clusters. Let me use this. Run this one first. Okay. And then we are going to look at the labels. We are going to pass the labels in our data frame. So when we are going to pass the labels in our data frame, it's a simple approach. How we do it? We have the data set. We'll say clusters label. And then this will give me a new column in my data set. And then we're going to pass the labels. How we do that? We just pass the value here. Okay, now let's look at the data frame, how the data frame looks like. As you see, data frame have my cluster label, right? So this gives me an idea about, okay, this guy is age 19, income 15, and spending score 39. He's under cluster level 4. Okay, so and as so forth so on. Now we have seen this in a tabular form. What we can do, we can create a simple graph of this. Basically, when we see the graph, then probably we'll realize how the performance of the cluster is. That will gives us a more idea actually. So what I'm going to do here is change few things. Change label here. Any question so far? Okay, no problem. So let's just show this real quick. Okay, so as you see here, this is the cluster as we have seen. So the first graph is basically a graph between spending score and age, and these are the distributions. And as you see, the color here is based on the cluster. So 0, the red one is 0, and the blue one is 1. So as you see, the red one is aligned between 40 and 60. So that's all this cluster, 0 cluster. Similarly, the green one is the cluster with a high spending score, but age ranging from some between 25 to 35. Similarly, the blue one is a high spending score with the young people. Similarly here also. So this, when you do the data analysis, you basically provide all these details to the business team about the cluster. You provide a write-up to them to provide the details on what each cluster means, and based on the goal of your marketing analysis, you provide them suggestion how you're going to use these clusters in your upcoming market campaign. Any questions here? I'll stop for a minute. Let me see if there are any questions.
There are no questions on the chat. Guys, any
Okay.
questions, doubts? If you want to ask, feel free to ask them.
All right. So far we have discussed the k-means clustering. So that's how you create a segment. I mean, cluster, we call it data analysis, and segment is a broad term which we use in the analytics industry. Segmentation sometimes means like filtering also. Like as I told you earlier, that when you go to Google Analytics dashboard, you will see segment, and segmentation where you can apply a segment based on geolocation. You can apply a segmentation based on the product customer have bought. So all those segmentation you can do. But when you are going to create your own program to segment your customers, then you can use k-means algorithm approach. All right, so let's talk about association rules. So association rules is also a machine learning algorithm where we learn about how the variables are basically related to each other in the data set. So it's very common for any company to associate one product with other or one customer with other. It's very common. And so the problem we usually try to solve is first, how we can understand this association, how some of these variables are related to each other, and if it is related to each other, then how much and what action we can take to basically increase our sales. So all of these things are completely related to how you increase your sales. You know, um, like the data analytics manager will basically tell you to create an association between a different set of customers, and then based on the result what you're going to provide, he's going to take some actions based on email campaign, based on phone call to the customers, based on some changes in the processes, whatever action that manager will take. It's based on the company overall decisions of marketing. Okay, so let's start on association. So in association rules, I'm not going to talk about a lot of code, but I'm going to talk about how basically we how basically we understand association. So I'm going to talk about that example, not via code. I have provided a link in my appendix where you can go and look into the code, because we have very less time probably to discuss the association rules through the code. So we will park that. Maybe when we have next time we'll have session, probably I'll dig into the code a lot. So let's try to understand association rules. So association rules, we try to figure it out with the simple example. So you go to market and you buy eggs. You go to market in next time, like day after, like after you buy the eggs, day after you went to buy bread. So you bought bread one day, you bought eggs one day, and then third day when you went to the market, you bought both things together, like you bought eggs together and with bread. So basically, uh, a market like the grocery market, Whole Foods, or companies like like Stop and Shop, they try to align their product based on the ease of the customer. So for example, you would see that Coke will be available mostly close to the freezer, where you will see frozen foods like the pizza or some sausages and all those things. You know, Milk will be available close to the egg section. So eggs and milk and juices also together. So people who buy milk probably will buy juices also together. So, but how they decide these and how they improve these things in the shop, that is also part of the data analysis. And then either you can observe these things, or either you find it through the data analysis. Like if you have a 500 store United States, you cannot you cannot hire 500 people just to observe the customer behavior in the store, and then you note it down on a paper, and then you reshuffle your aisles. That is going to be really difficult for any store manager to analyze. So best thing is that you have the data from the store, like the purchase data from the store, and then a data analyst basically will create association rules to tell the store manager each and every store, saying that, hey, in this store, these are the metrics, and you should take these are the different recommendations I am letting you know, so that you can adjust your aisles and the products on the aisles to increase your sales. So that's one of the very common usage of association rules, especially in the retail industry. Okay, so let's take a simple example. While calculating association rules, we basically look at three things. When you run the algorithm, as I said, the algorithm which you will run is a priori algorithm. It is available in scikit algorithm, like library from Python, and it takes few inputs. But what I'm talking about here is more in terms of the output, because output is important for association rules to understand, because when you run the algorithm, it's just 1 or 2 lines of code, and the other things would be the data cleaning, understanding the data, and all those things. So the algorithm will give you 3 key metric. Okay, whenever you run the complete data set or some portion of the data set, like if you take only few columns and then you run the algorithm. So it gives you 3 important metric. One is support, one is confidence, one is lift. Okay, so let's take a simple example. Like we have bread purchases in 500 transactions and egg purchases in 350 transactions. And there are some transactions where both bread and egg has been purchased. 150 transactions where both has been purchased. Okay. Now let's understand support. In the output of the algorithm, you will see support. Support is one of the metric. And what is support? Support of an item. Like suppose I want to know how many people, what is the support of an egg? So I would basically do total eggs purchased, okay, independently divided by the total transactions. Suppose I have total transactions of like, you know, thousands. That's the total transaction. So we can divide 350 by 1,000 because here, so that's the support. So that's total purchases is 350 of X. You know, we are not, this is inclusive, this one. So total purchase is 350, 1,000 is the total transaction. So we'll divide this, and we'll get the support of an egg. That is what we call support of any item. It's a very simple mathematics, not very complicated. But now confidence. So confidence is important to understand, and this is one of the key metric. So you want, as a store manager, you want to know, I have bought eggs. Okay, if I have bought eggs, then in my basket, what is the probability that I will have bread too? That is what your confidence is. So as you see definition, how likely it is for one item to be purchased, given that another item is also purchased in your basket. So, and you define the confidence. Okay, so for example, we want to understand how likely is that a customer will buy bread when egg is already in their basket. So, and how you calculate? You calculate it this way: support of egg and bread divided by support of egg. Okay, so this is the confidence. And then the most important metric which you will look at in association rules is lift. Okay, lift is basically is a measures of how much often basically antecedent and consequent, like when what you have purchased, if and then occurs together. How many like what is the probability that eggs and bread are being bought together than buying independently? So that is the lift. So lift is one of the important metric in your association rules. And when you look at the lift, there are three things you should remember in the lift. Okay, one of the important thing in the lift you should remember is basically you will get lift score either less than 0, I mean less than 1, more than 1, or maybe you will use lift is equal to 1. You will get these things, sort of thing. So if your lift score is like less than 1, you know, if lift score is less than 1, then there will be very less association. So you will say that it is highly unlikely that people will buy bread if they're buying eggs together. So if lift score is less than 1, then the association rule is like very negative, like you shouldn't be putting these things together on the aisle. Similarly, if the lift score is high, that means very there's a high chance that these two products are being bought together. So why don't we keep those two things together near the aisle? You know, like soda and chips. You know, like side by side. If people are buying soda, people are also buying chips and some frozen food. But if there is a lift score is 1, then it means there is no association. So you keep wherever you want to keep those two products. It doesn't matter. You can keep together also, you can keep far also. It is not impacting the customer purchasing behavior. So that's how you interpret the lift, because lift is one of the most important metric in association rules. So I have put together a link in the document. Go through that link, which has a process like how you get support, confidence, and lift, and how you interpret these three different variables. And concept of probability is also important. in association rules. Association rules are not only limited to like the market, like retail market. It is also it can be extended in most of the fields. Like let's take an example of travel industry. You know, travel industry where you know, people like the different flight companies would like to understand the association between different airlines, and the delay happening association between different airports, like how efficient this airlines is in this airport and that airport. So those sort of associations you can determine through association rules also. There are several examples out there. If you go to Kaggle, you can look into that. You can find a lot of data set, a Kaggle um, data set on association rules. Okay, so you will find a lot of different examples of association rules. I'm just giving you one or two examples. Any questions on lift, support, and confidence? Hello, any questions? No? All right, great. So let's move on to our next slide. Next slides is basically um, digital marketing. So digital marketing is a very broad concept. Ashish, do you want to talk about a little bit on this?
Sure. Okay, so guys, digital marketing. Actually, I started my career with digital marketing, so this is like a very close to my heart kind of topic. So we all know what marketing is. It's like reaching out to right people at the right time. But now, since the customers changed habit, they are like not just browsing through the physical newspaper, but they started to more browse through the e-papers, the websites, the apps, etc. So organizations also have to align and move their marketing stuff over to the digital channels. So any marketing activities that organization engages into over the digital platform, we will group them under the digital marketing. So for that, of course, you need a digital touch point. That is, it can be your website or mobile app, uh, or just a blog hosted on Blogspot or a WordPress.com. So you have your digital touch point, then you use different digital marketing techniques like search engine optimization, the social media marketing. There are paid campaigns that your organization engages into, or the email marketing, where people ask for your email address and they reach out to you with different offers or updates. And all this is measured using the analytics tool. So we have seen the analytics tool, Google Analytics, Adobe Analytics. So all the promotional activities are targeted with one purpose: to send user back to your digital touch point where he can take the necessary action. It can be a subscription to your service or a purchase or just to watch the content. So analytics tool will let you know what are the different channels people are using to come back to your website and which is the most effective. So if you see that the paid social media campaign is giving me the most or the biggest ROI, that is I invest $100 and I earn $1,000. The analytics tool will let you know that. Then you can say, okay, I'm going to cut my budget on SEO activities and going to increase it on the social media paid campaigns. And this tweaking will be happening on day-to-day basis, and analytics tools will help you with that. And then next we have is the content marketing tool, design tool. So it involves, so what's content marketing? So it's marketing of your content where you directly do not sell your services, but you try to sell the content around it, build your brand over the internet. Like you keep on blogging, after 10 blogs you post something to promote your product. So this is content marketing. There are different tools, there are different designing tools. uh, Designing tool, we all know, like Photoshop can help you to build the virtual element, like photos. But there are nowadays a number of different websites which help you to do this, like the canva.com, the most popular one. So these are the different tools available which help you in content marketing. There are different tools like Hootsuite, which you can go and explore. It's free of cost. It helps you to manage your social media presence and promote your content over the social media. So this is like a small brief on what the digital marketing is and what are the different tools used in the digital marketing. Over to you, Abhishek.
Yeah, absolutely. Absolutely. So um, we have been doing a lot of digital marketing since last 10 years. And the first link here, what you see is workflow of digital marketing. When you look at that link, it gives you an idea about what are the process to think about digital marketing in a company, what all steps you should be taking to run a digital marketing campaign. So you should learn from that link. Um, and as I said, like as Ashish mentioned, these are the tools. Try to learn some of these tools and techniques. Right now, some of the very demanding tools and techniques in digital marketing is, how you are running your advertisements on social media platform, because social media is creating so much leads and revenues for the companies. Uh, even though if there is need of SEO all the time, social media is becoming one of the key here. So whether you are using Snapchat, Instagram, Facebook, and TikTok, these are the different popular social media where people are spending too much money and they're getting leads actually. So that's why they're spending money. Twitter is one of things. Twitter, LinkedIn, Quora, all these are like social media platform. You know, people have started doing marketing on Medium as well. So yeah, so social media marketing, try to learn how to generate leads through social media platform, how to run the ads on the social media platform. And when you use Facebook ad platform, you will see an option to create segment through different CSV file of your data. You will see that Facebook provides an option to create segments based on the rules. Like you want to create segments for the customer who haven't clicked a button. Okay, you want to rerun this different campaign on the same sort of customer, so you can do that. So all those things, a lot to learn. Digital marketing is very, very vast field. Focus on one or two things. I mean, email marketing tool is like huge. When you get into email marketing, you will see how email marketing works. It's not just writing an email. How much effectively you are making money from email marketing tool. When you go to the company, it's going to be simple. This much money I'm spending in the email marketing tool every month. Every month we are spending $1 million email marketing tool, and different process. How much money we are getting, how much money we are making in terms of revenue, in terms of profit from this whole process. So when you go to the company, you have to be very effective in terms of strategy. Otherwise, it becomes very challenging. Tell your boss that this tool is not working for you, that tool is not working for you. So focus on the strategy and effectiveness of the tool. One or two tools, focus on that, and then take it from there, rather than learning every tool together. That shouldn't be a good idea, I guess. Rashish, what is your suggestion?
Absolutely. So when I started my career, I was doing everything. I was like literally creating images in Photoshop, uploading them on the website, then do social media on it, send emails. So I started with everything. But as you make progress in your career, you will realize that you will choose area of your interest. Some of you will become like social media managers. Some of you, like Abhishek and me, we went into analytics. We are like analytics consultant. Some of you will go and become email marketing managers. So it all depends on your interest, but when you go and make progress in your career, you will choose, most of you will choose one specialty and make career out of it. Some of you might choose, hey, I want to be like, do everything. They will become like team leads. So they might become managers who manage five different teams. Like one team is into email, other is into social, so it all depends on your interest, but definitely a huge career opportunity here. Do not ignore it. Digital marketing is huge.
Yeah. Yeah, and if you have a little bit of technical knowledge, probably you will easily excel, because you will not find a lot of people who have a technical knowledge in digital marketing. If I mean, one of the things so far I have noticed in the digital marketing here is that you have to be creative. Marketing cannot run without creativity. If you are having creative idea, you will excel in marketing, because marketing is all about making changes fast to get more revenue, more leads. Um, and if you try to sit on a marketing campaign which is not giving you enough revenue, I mean, just throw it in dustbin. I mean, it is no of use, right? You're just wasting your money, because money, if you don't, I mean, like, this is very famous saying that when you run a marketing campaign, you lose half of your money for nothing. Like, literally, you will throw that money in dustbin, and you pay that money to Google, you know, and you will not get anything, any penny you will not get for that. So focus on strategy, focus on creativity, and some part of technical skills also matters here. Any questions related to this session? Any questions related to association rules, segments, any further learnings? I'm going to share my slides again because I have a couple of things actually. Uh, so this is my, okay. All right. So next step for you, revise the session, all of the session, I would say. Pick your favorite topic, such as web analytics, linear regression, Python skills, segmentation, or association rules. Start working on that topic and write us back if you have any questions. We are happy to answer any of your questions. In case you want to schedule any one-on-one session, I'm happy to do that. But give us a heads up of like 3 to 4 days. Send us your questions before that, and then we will be joining with you any one-on-one session if it is required. All right.
Perfect.
I have some appendix here. So these are the links which you can use to learn more on k-means clustering, a priori algorithm, and digital marketing tools. Thank you.
Great session, Abhishek. So, guys, we have posted, rather, I have posted the links to mine and Abhishek Twitter and LinkedIn accounts in the chat box. Please connect with us if you have not already, and we are available over Twitter or LinkedIn chat if you have any further questions for us. Email, of course, remains the topmost channel of communication for us. Abhishek, 5 continuous weeks you have spent with us. Thank you so much for your time. It was very helpful session. I am now pretty much confident that I know where I started, where we started, and where do we
Yeah.
stand. So I'm pretty confident over the Python now. It proved to be a very good recall session for me. People who just started with Python, we don't expect you to become pros with the help of this session. Of course, you have to practice, and we are here if you want any kind of help. Abhishek, thank you so much again for the time and the energy that you have spent for us, and I hope we will connect again in the future as well.
Yeah, sure. Thanks, everyone. Thanks for joining us. Have a great weekend. Bye-bye.
Thank you guys. Take care. Bye bye.
Thank you.